Hey guys, in this video, we can discuss Leetcode 1428, the leftmost column with std of 1. So basically, the input will be a row-sorted binary matrix. So binary matrix means the input will be a matrix with zero or with values only having like zeros and ones. And the row-sorted means every row is sorted. So since the values are only 0 and 1 and it's sorted by rows, so every row we gonna see zeros first and then see the ones. So let's look at example at line 226 here. So the input for every row will be all the zeros and the ones because it's row-wise, it's sorted, and then it's a binary matrix, so we only have zero and ones. So to solve this problem, to find the leftmost column with at least one, which is like for the given input is this column. So this is a column, leftmost column with at least a one, right? So what we can do is like we can start from this position. And then what we can do is like we keep moving left until we reach the zero. And then which is here, and then we move downwards, which is here, right? So we started from here, keep moving left until we reach a zero, which is gonna move to here. Now we move downwards to this position, and then we still do repeat the previous step, keep moving left until reach the zero, so which is here. So we move left and reach this zero, and now we move downwards. So this is still a zero, so we do nothing. We move downwards, where we reach here, and then we keep moving left until we reach a zero, which is here. And now we're moving downwards, which is here. And this is the end of the rows, like this is the last row, so we stop here. So we end at this position, right? So the leftmost column with at least one is the right column, is the column on the right for this position, so which is this column. So this is the column with the leftmost um, column with at least one. All right, so basically for this problem, it's simple. Like we start from the top right corner and then keep moving left until we find a zero, and then moving downwards, and then keep moving left until we find a zero, and then moving downwards. So let's start coding it out. So first of all, we need to get the size of the matrix to binary matrix. So this is a given interfaces for the input variable. All right, and then now we can start position. So the current row, current column would be the first row 0, and the column will be columns -1. So this is starting position, right? Now we're gonna move from the start position and move to the last row. So while current row is less than number of rows, and current column is larger than equal to 1. So if we reach the leftmost column, then we will know like we already we can like the first, if we find the one like at the first column, then we can just early end to return the column 0. So if binary matrix get the value, current row and the current column, if it's equal to 0, right? Then we increment the row, sorry. Current row be incremented by 1, else current column, right? We just move leftwards. All right. So now once we finish the loop, if current column equal to equal to columns -1. So this is the edge case where like the input is all zeros, right? So if the input is all zeros, so we stuck at this column, current column, then we just return -1 because we cannot find the column with a 1 because the input is all zeros. Otherwise, we just return current column +1 because we need to find the column on the right with this 0. So this current 0 on the right. All right, so let's run and see how it goes. Looks good. Yep, makes sense. So basically for time and space, so space-wise, it's a constant space because we don't use any other storage. For time, we just loop like uh, one direction and then like row-wise and column-wise, right? So it would be R plus C, so the number of rows plus the number of columns. All right, so this is the end of the video, and I'll see you guys in the next one.